Alright, so we now move on to Echem, the first topic called the three-phase AC. Three-phase AC. Okay. Now the first point is about a phasor diagram, a very important phasor diagram. This that you have three short arrows here, alright, and this is called VAN, VBN, and VCN. Now because these three short arrows, they are equally spaced in the circle, so they are actually 120 degrees apart. So this is 0 degree, and this is minus 120 degree because it's below 0 degree, and then here is positive 120 degree. Any problem in remembering this phasor diagram? You must. Okay, so three short arrow. Then you have these three long arrow. Alright, and this three long arrow, because this is ABC sequence. ABC sequence, right? So the way they remember how these three arrows are named go like that. AB, so this is VAB. Next one, BC, so this is VBC. The next one, CA, so this is VCA. Right? It goes into a cycle. Okay? AB, BC, CA. Right? So VAB, VBC, VCA. We always go in this clockwise manner. Now, the angle between this long phasor and a short phasor is 30 degree. So this is 30 degree. Because here is 30 degree, right? Here is minus 120 and then here is 30 degree. So therefore this is 90 degree. So here is minus 90 degree. And here is 120 degree, here is 30 degree. So here is 150 degree. Must remember this phasor diagram by heart. When I say by heart, means you should be able to reconstruct it anytime that you like. Alright? So this is called ABC sequence phasor diagram. Okay, let's do it one more time. To construct this phasor diagram, I call it the ABC sequence phasor diagram. ABC sequence. It's this three short arrow. So VAN 0 degree, VBN minus 120 degree, VCN 120 degree. Right? Then the three long arrow, right? VAB, how about this one? VAB, then VBC. Next one, VCA. And what is the angle? That is 30 degree. This one is minus 90 degree because 120 and 30 so become 90. 120 and 30 become 150 degree. So this is called the ABC sequence phasor diagram. So if I were to ask you for the angle, right? I say ABC sequence, VAN as the reference. So this one is the, when it's 0 degree means he's the reference. He's the reference. Right? So VAN is 0 degree. How about VBC? It's minus 90 degree. VBN minus 120. VCA 150. VCN 120. VAB 30. So if you have the diagram, just look and then the answers out. You look, the answers out. It's like a lookup table. Lookup table. Alright? So now we move on to another phasor diagram, which is called ACB sequence. Just now was ABC sequence, so another three phase. If it's ACB sequence, your phasor diagram is still the same. The shape, the look is the same, but the name is not the same. Now it's ACB sequence. So again, you have three short arrow. Alright? So this is VAN, VCN, and this VBN. Can you see? ACB. Just now was ABC, now it's ACB. So here is 0 degree, here is minus 120 degree, here is 120 degree. Okay? Alright. After the three short phases, then you go to the long one. Okay? And the long one, you will start with VAC, and then VCB, and then VBA. So this will be VAC, and VCB, and this is VBA. Alright, got it? So what is the angle? again is 30 degrees from each other. See, here is minus 120, BCN is minus 120. So here BCB is equal to minus 90 degrees. And then here is 120, so here is 150 degrees. So in this phasor diagram here, who is the reference? He is the reference. The 0 degree is the reference, so he is the reference. Okay. Alright, so now let's talk about changing the reference. Changing the reference. If I do not want this to be the reference now, alright, so now I'm talking about reference. Reference. So my phasor diagram here, he's my reference. When he is VAN as reference, VAC is 30 degree. VAC is 30 degree. And VCB is minus 90 degree. That's when VAN is a reference. So now if I were to change, VAN is no longer my reference. Okay, I want VAC to be my reference. That means I don't want him to be the reference anymore. So if I want VAC as reference, that means I want him to be 0 degree. And how to make him 0 degree? I'm minus 30, right? If I'm minus 30, everywhere I must go at minus 30 degree. So if VAC is reference, then VAN is minus 30 degree. How about VCB? Minus 90 minus 30 become minus 120. How about VCN? Minus 120 minus 30 become minus 150. Okay. How about VBN? 120 minus 30 become 90. How about VBA? 150 minus 30 become 120. So can you give me the new angle when I change my reference? What you need to do is, the one that's to be made reference becomes 0 degree. How to make it 0 degree in minus 30? Everywhere you go at minus 30 degree. Got it? And that is called changing the reference. Okay? Right, let's try the exercise. On an exercise on ABC sequence. Okay, ABC sequence. If it's ABC sequence, that's our phasor diagram. VAN, VBN, VCN. And here's 0 degree, here's minus 120 degree, here's 120 degree. Alright? Then the long faces. Alright, so this is VAB, here's VBC, here's VCA. Okay, you should be able to produce it very easily on your own now. And here's 30 degree, here's minus 90 degree, here's 150 degree. Okay, so now are you able to answer this question by looking at the diagram? If I say VAN as reference, what is VAB? Of course it's 30 degree. How about VCN? 120. How about VCA? 150. No issue, right? Because just look and the answer is up. So now the question change. Okay, I don't want VAN as a reference. I want VAB as reference. Right? If I want VAB as reference, what are these angle now? They should be different now. Yeah? How do I make this as a reference? I change this to minus 30 to become 0 degree. So everywhere I must minus 30 degree. So VAB is 0 degree. VCN, 120 minus 30 become 90 degree. VCA, 150 minus 30 become 120 degree. So that is called a phasor diagram, phasor angle when I change reference. Okay, so we have these two phasor diagram called ABC and ACB sequence. Right, third point. If VAB is 30 degree, then I ask you what's VBA? right? A lot of you will say that VBA is minus 30 degree. That is wrong. Now, when the subscript change, you find the angle, that is the meaning in phasor diagram. If VAB is 30 degree, that's what it means. Here's the 0 degree, right? VBA is a phasor diagram, it's a phasor that's opposite, pointing to the other way around. So VAB is like that, so this is VBA. So what is the angle of VBA? Here is 150, right? But this 150 is below 0 degree. So the angle is VBA is minus 150 degree. That's the correct answer. So when you are given one phasor and then when it is so-called switch, the subscript here switch, then you have to draw a straight line to get the answer. Get it? Okay, let's try. Alright? If I say this is VBA is minus 90 degree, right? Okay, maybe I produce the phasor diagram and then we try on that. Let's also give us a practice of the phasor diagram. So it's ABC sequence. Okay, ABC sequence. So it's this, and this. So it's VAN 0 degree, VBN minus 120 degree, VCN 120 degree. Right? Then the long one is VAB 30 degree, VBC minus 90 degree, and VCA 150 degree. Okay, now based on this phasor diagram, let's try. I ask you for VBA. So VAB is 30 degree. So what's VBA? Is VAB 30 degree. VBA is the other way. So here is 30 degree, here is 150. So VBA is minus 150 degree. Right? Now how about VBC? VBC is minus 90 degree. Then I say I want VCB. VCB, can you see? VCB means switch, it means the arrow now pointing upwards. So that's VCB. So it's therefore 90 degree. 90 degree. How about here's VCA? So VCA is 150 degree. Now I want VAC. That means I switch. VAC is the arrow that points the other way around. And here is 150 degree. Here is 30 degree. Alright? So VCA is therefore VAC is therefore minus 30 degree. Get it? So these are called the two standard phasor diagram that you must know by heart. They are the ABC sequence and ACB sequence. Can draw the phasor diagram in a standard manner, and when I change the reference, you are able to give me the angles accordingly. Right? So that is changing the reference. So now let's move on to the two basic circuit, which is called the star circuit and the delta circuit. Okay, maybe we pause for a while, then we will